Alright, so I'm going to call on, let's just get the first two out of the way, and then I'll call on a couple more from there. So, Adam, you're going to help me with rewriting, and then let's also go to Kara with helping me with rewriting. So, Adam, how do we rewrite y equals 4 to the x as a logarithm? Alright, well, let's kind of go back. So last class when we were doing this, what was our pop culture reference we used here? All about that base, that's right. So when I'm looking at this exponential, Adam, what is the base of the exponent?
4.
Okay, so when I rewrite this as a log, I'm going to make sure that 4 goes in the base of the log. So let's do that here. I'm going to write this as log base 4. Awesome. Now in the parentheses, who can tell me what we call the parentheses? What is a vocab word there? Think debate. It's the argument. Good job, okay? And remember, your arguments have to be positive. Okay, so what goes in the argument? The y, yeah. So the exponent is what we set it equal to. And then whatever the base of the exponent is, that's the base of the log. Whatever it was equal to becomes the argument. That's how we rewrite that, okay? It's important you know how to do that because we use this skill in almost everything, okay? Kara, what about when we're going from a log to an exponent? What's our pop culture reference there? Remember we were all chanting, yes, circle of life. So will you tell me how you'd rewrite this? Awesome. We start at the base and we make our circle of life 3 to the y equals x. Awesome. Good job. Okay, cool. So now let's go over to these 6. There were 6 here. I'm going to first call on like 3 or 4 of you guys to tell me how you simplified them, how you evaluated them, and what your thought process was there. So Angelina, will you take one? Brandon, were you here last time? We'll let you pass. Brinley. So Angelina, Brinley, and let's just do one more. Ofa. Just choose one of these and tell me what it would become and why. So Angelina, start us out. I'm going to give you the first one. Let's just pretend this is set equal to x. How would you use circle of life here to simplify that? To turn it into an exponential, yes. Yeah, because we got to go like this. So what power of 3 gives you 9? 3 to the 6 would be 27. There we go. She was up late singing. We'll give her a break, okay? Okay, so log base 3 of 9 is 2, because when I rewrite this, it says, what power of 3 gives me 9? Well, 3 squared is 9, so if you went in your calculator and put in log base 3 of 9, it would turn into 2. What buttons do you push to put that in? Math up, right? That's how you get log base, and you can check it. Okay, Brindley, will you just choose another one? This one, so just the one right next to it, under it, okay? So this is correct, good job. If we let it be 1, 2 to the 1 is just 2 still, stay the same. There you go, it's going to be 0, nice job. Alright, Ofa, can you take another one of these? Okay, great, go ahead. Nice job. If it had just been 4, we would square it, but if it's 1 over 4, then we know we need a negative to move it to the denominator. Okay, so those were the 3 kind of the intro ones. The other 3 were a little bit more tricky. Ofa's was a little tricky too. But does anyone think they know how to could explain how they would do the other ones? Go ahead, Hiram. He was like, I was just scratching my nose. No, you were volunteering right there. Go ahead.
So I think for like the log 26 is 27, it would be 1/3 because like if you do 1/3 then it becomes cube root.
There you go. So how do I get from 27 to 3? You have to take the cube root of it, right? 3 times 3 times 3 is 27, so we want to do the cube root. And you said cube root is the same as a 1/3 power, so you are correct. Nice job. 1/2 power is square root, 1/3 power is cube root. Cube root of 27 is 3. There you go. Nice job, Hiram. Anyone think they could see what it would simplify to on the other two? Go ahead, Izzy. Yes, now good. Now why is it 1.5? So it's kind of tricky here. We're saying what power of 4 gives me 8? Well, 4 to the 1 is 4, right? And 4 squared is 16, so it's something between 1 and 2. But we can't really get there evenly. But let's think about, what if we did 2 steps here? Is it possible to get to 8 if maybe we like squared it, or if we cubed it, and then tried to work backwards? And the answer here is actually, let me just tell you what the answer is. It's like Izzy said, it's 1.5, but I think it's easier if you think of it as a fraction 3/2. Now, if you're looking at 4 to the 3/2, let's do that one step at a time. What is 4 cubed? That's 4 times 4 times 4, which is 64. Now, if we do the square root, or 1/2 power of 64, what is that? 8. So that's what it's doing here. In order to get 4 to 8, it's like, well, we can't do that in just one step. Let's cube it and then square root it, and that's how we get to 3/2, or 1.5. That's a little bit trickier because we had to do 2 steps, right? So that's why that one was last. But good job, Izzy. Now let's go to this last one here. Let's just go through this together. 2/3 to what power makes it 4/9? Or sorry, 9/4. Now if it had been 4/9, what would you just have to do to get from 2/3 to 4/9? Square it. But not only are we squaring it, we're flipping it. So how can you flip and square at the same time? There you go. So this is going to become -2. And you could check that on your calculator, right? Okay, cool. Do you have any questions on this? So next time you're going to have a quiz on exponentials and logarithms, rewriting it and evaluating it. That was the main thing we learned last time, right? Today we're going to go over some properties and also some graphing. That will be on your quiz as well, okay? All right, well, let's just keep on rolling with this fun stuff. So today, what you're going to do is you're going to use the properties of logs to expand and condense them. Expand means you have one log and you make it many logs. Condense means you have many logs and you make it one log. And then we're going to talk about how to graph using the inverse, okay? We kind of talked about inverses last time, but we were more just like describing transformations. And today we're going to be actually like using them and graphing them, okay? All right. Here are your 3 properties of logs. And they're already written down, but I would actually recommend that we write it down again, just because you remember things better when you write it down. So the first property here is called the product property. In math, what does the word product mean? What does it go with? Multiplying, multiplication. Good. So if I'm looking here, notice how there is multiplication in the argument. So I have a log base b of r times s. So that's multiplying, right? Log base b of r times s. Well, what the product rule says is that if we have multiplication going on here, I can write it as 2 logs that are adding. So I'm going to write this as log base b of r plus log base b of s. This is your first property. It's called the product property. Now I can use it both ways. If I have one log that's multiplying in the argument, I can write it as two logs that are adding. Or, other way around, if I have two logs that are adding and the bases are the same, I can write it as one log where their arguments are multiplying. Okay? Now let's prove that this actually works. I want you to get out your calculator. And we're just going to put in a common log here, okay? So I want you to put in common log, and then in the parentheses do 2 times 4, and push enter. And it should give you an ugly decimal, right? Now put in common log 2, close the parenthesis, plus common log 4, close the parenthesis. See if it gives you the same ugly decimal. And it does? Yes, that means the product property is true. You could do that for like any numbers as long as it was a true statement, okay? Cool. Was everyone able to check that, or do you have questions on what buttons to push? Okay, let's go to the next property. Next one is called the quotient property. What does quotient mean in math words? Division. We're going to be dividing. So just like the product rule where we were multiplying in the argument, now we're going to be dividing in the argument. So we're going to do R over S. If we see division, I can write it as two logs that are subtracting. So in the product, they're multiplying, so I add them. In the quotient, they're dividing, so I subtract them. And the way it's written out here is I only have 2, but really you could have like 3 of them, right? You could multiply a whole bunch of things and then have a whole bunch of logs. We'll see that later. Let's test this real quick. I want you guys to go to your calculator and do common log 8 divided by 2. See what that's equal to. And then see if log 8 minus log 2 gives you the same ugly thing. Did you get the same ugly thing? Nice. Okay, last but not least, we have the power property. When we're talking about powers, that's referring to exponents, okay? The power property says if my argument has a exponent, or a power, then that power can actually become a coefficient of the logarithm. Let me show you what I mean. So if I have log base b of r raised to the c power, like that. So see how the argument has an exponent? The power property says we could just bring that c down to be a coefficient of the logarithm. So that's equal to c log base b of r. We could also go backwards and say if we have a coefficient, that becomes the exponent of the argument. Okay? Now let's check that last one here. I want you to do log common log of 2 cubed. Now you've got to be careful when you put this in. The cube is inside the argument like this, okay? Not on the outside. So do log of 2 cubed, and then see is that the same as 3 log 2. Did it work? Cool. Okay. So what we're going to do is we're going to do a lot of examples where we're going to be given a log, and we're going to use these properties to expand it to many logs. Or we'll be given many logs and we condense it to just one log. Now I did forget to mention one thing. When you're talking about the power property, I'm going to put a little asterisk here. You can only use this if afterwards you put your fist in the air and say, I've got the power. You know that song? Okay. It's going to be a rule, so get ready for it. All right. Okay, so here we go. We've got log of 8xy to the 4th. Now, first question, what is the base of this log? I hear some mumbling, but someone say it louder. 10, thank you. If you don't see it, what kind of log is it? Common log, which is base 10. Now that just means when I expand this to be many logs, then I'm going to they're all going to be base 10 as well. Keep the base the same. Okay, so now look at what's going on inside the argument. What's happening? What was that, Allie? Okay, so there's an exponent. That's very true. What else is going on? There's multiplication, right? The 8 times the x times the y. And then we also see the power. So we're going to use product property and the power property. Now, this is another pop culture reference here. Ogres are like... No, they're not like layers. They're like onions because they have layers. Okay, good job. So this argument is going to be an onion that we're going to be like peeling layers off of. So when you peel off the parentheses, what's happening first? Is it going to be the exponent or is it going to be multiplying? These guys are all multiplying first, right? Now what if the whole thing had been raised to an exponent? Then I do the power property first. But only the y is being raised to the exponent, right? So I'm not going to do the power property first because what I see after I undo the first layer is multiplying. So I'm going to say, you know what, let's do the product property first. What the product property told us is that if you're multiplying, we can rewrite those as logs that are adding. How many logs am I going to have here? Well, how many things are multiplying? 1, 2, 3. So how many logs will I have? 3 logs that are going to be what? Adding. So I'm going to say this is log 8 plus log x plus log of y to the 4th. And I put the parentheses just so I don't confuse myself later with like bases or exponents or things like that. So that would be our first step here in expanding this, is I'm going to write this as 3 logs that are added. Is that following what we said here? Yes. Just because I wrote it as 2, if I had 3, it would just be 3 or 4, there'd be 4 logs, okay? Okay, cool. Now let's go to what Allie was saying. Now that I have split this up, I go to the next layer. Nothing's really going on there. Nothing's really going on there. Well, technically, I guess we could get into this since it's honored. Could I rewrite this? Could I simplify this as something being raised to a power? What would that be? 8 is 2 cubed, right? So I could write this as log of 2 cubed, okay? And I'm going to keep the rest the same. Now, why would I do this? Which property can I use next, guys? The, not product, because it's not multiplying. Power property, that's right. So now when I say let's use the power property, what that's going to do, we're going to actually use this twice here. We're going to bring the 3 out in front here and the 4 out in front there. However, if we're going to do that, what do we have to say? Yes, but with more power than that, I was like, that's not very powerful. Alright, so I've got 3 log 2 plus log x plus 4 log y. And there you go. This is fully expanded and simplified. That's as good as we can make it. Okay, does that make sense? We only use 2 properties. We use the product because they're multiplying, the power because there were powers. And so now it looks like that. Let's keep on going. That was your first example. We're going to do several of those, okay? This one is going to get a little cray-cray. Let's try it out. So we've got ln. And then inside the argument, we've got the square root of x squared plus 5 over x. Okay, now, a lot of times people get scared because they see square roots, and they're like, oh no, radicals. But what do we don't want to think of them in terms of square root. How could I change the way it looks, but still keep it the same? It's a 1/2 power, right? So when I see a square root, I'm going to think 1/2 power. So I'm actually going to start off by just saying, hey, square root of x is just x to the 1/2, right? So let's rewrite this as ln of, and in the top we have x squared plus 5 to the 1/2 power, and then that's all over x. Okay, cool. So if you see a square root, just think of it as 1/2 power. If you see a cube root, 1/3 power. Now let's go and peel this onion here. I'm going to peel it open and say, which property do I use first? What is going on the very outside? So I see this 1/2, yes, but is that applying to the x as well? So that's going to be our middle step, okay? But what about what's happening on the very outside? We're seeing division, see that? This is being divided by this. If the exponent had applied to everything, we do the exponent first, but it only applies to the numerator, so let's use the quotient property first, so we can then use the power property, okay? So I'm actually going to call on Tao. Can you tell me how to rewrite this using the quotient property? Yep. So let's do numerator first. So we have x squared plus 5, and then that's going to be raised to the 1/2. Okay, so there's your numerator. Keep going. So then, yes, good job. ln of the denominator, which is just x. There we go. We use a quotient power, and then that made it so we can write it like that. Okay, good job, Tal. Now what would be our next step, guys? The exponent here, that's going to be our power property. Let's bring down that 1/2, so that 1/2 is going to come out here. So this is going to be 1/2 ln of x squared plus 5 minus the ln of x. Now we use power properties, so we got to say, got power, cool. Let's keep going. Can we keep going? Is there any rule for expanding if you're adding? We've got one if you're multiplying. We've got one if you're dividing. Is there one for adding? Nope, so this is actually as far as we can go. However, let me just show you one thing. Instead of thinking of this as timesing by 1/2, a lot of times what will show up is this will be dividing by 2. So it'll look like this. It'll say ln of x squared plus 5 over 2. Now, in a couple minutes here, we're going to be working backwards to where we're starting with this, and we're trying to make it back to be one log. And sometimes people get really confused when they see divided by 2. They're like, I don't know what to do there. Well, just remember, dividing by 2 is the same as timesing by 1/2. And if you have a coefficient, you can bring it up to your exponent, and a 1/2 power is square root. So you're going to be doing the opposite here. So make sure you kind of catch on to your steps to make sure you can go the other way too. Okay, so there we go. That's as far as we can get it. Do you have any questions on that example? If so, please stop me. Let's keep on rolling then. Okay, I'm going to have you guys, I want you to turn to your neighbor or buddy, and I want you to expand both of these using the things we've been talking about, and let's see how you do. Okay, go ahead.